It's 2 o'clock, and we want to welcome you to the Kentucky Center for Mathematics. This is our afternoon Zoom session. This week, we are actually talking about focus on fractions. Today, we have Leah Dix-White. She is a regional consultant from the Louisville area. But I want to just mention for a minute that we have a virtual site, and our virtual site will house all of our KCM Zoom videos, and you will find series after series after series. And the three things that are located there are the presentations. In addition to the presentations, you'll find some handouts, and in addition to the handouts, you'll find a live recording of today. You'll see that we are interacting in a chat, but we also want to encourage you to unmute yourself, because one of the things that's important is that ability to hear you. And I think that yesterday's session was so wonderful, because many of you are beginning to feel like friends and know that this is a safe space for us to have those vibrant conversations, and that we really value your input. So when Leah takes a pause or she asks a question, feel free at any time to unmute and perfect, and unmute and go ahead and tell us what you're thinking about. So Leah is launching. We are talking about our focus on fractions has to do with addition and subtraction with common denominators. This is our fourth grade standard. And Leah, I sure do look forward to learning from you today.
All right, sorry about that, the little glitches there. I had to switch computers really quick. So today we're talking about addition and subtraction with common denominators. I thank you all so much for joining me and for your patience as we get rolling here. As always, you can visit our website to get information about all of our virtual sessions that we have. You can also visit our website to view sessions that we've had in the past, just in case you've missed out. I know how it is to get your daily math fix and how we need that. So we appreciate you joining us this afternoon. Today's session, we're going to start off, as always, with some research, given our topic. We'll dive into the standards briefly and talk about that progression, along with fraction operations and common denominators. And so there's three activities that I think that will be interesting for us to talk about and to look at in terms of this topic. I think they are great activities, and I've also found some digital connections that you can view. So if we're going through the PowerPoint and you see a QR code, you can use your phone or device and click on that QR code, and then you can go directly to the digital source that I'm referring to. And so that's something I wanted to share with you guys. And so be sure to look out for those things. So the research behind the work, these are three awesome texts that I'm sure that you've all seen or are familiar with, and they are also were referenced in the previous sessions this week. But the Lamont text gives you a great overview of teaching fractions and ratios for understanding. There's examples. Also the text in the middle, the Van de Waal, Karp, and Loving, and Bay Williams text. We're familiar with those authors. They provide a great formula for teachers, grades 3 through 5. And there's also a 6 through 8 edition. And then lastly, we have the IES recommendations, which I'm going to continue with that. So on Monday, Cindy talked about recommendation 1. Yesterday, Dee talked about recommendation 2. And so today I will be talking about recommendation 3. And with this recommendation, it's very important for us to give students opportunities to make sense with fractions, using area models, number lines, visuals, all before the formal computational procedures. So that's one thing that all of the authors had in common. The common thread is that students need these experiences before learning the procedures, before the algorithm. So, and I know I'm preaching to the choir when I'm saying that, but these are the recommendations, and rightfully so, because we can see as we progress in the standards and as we move along with this continuum with fractions, we have to have these experiences, these rich test experiences to help us in this learning progression. And so the standard that we're covering today is a standard that's covered in the 4th grade. And so we want students to be able to understand the fraction as a number. And to do this, we need to change how we talk about fractions in general. And we'll talk about that a little more later. But it's this idea of separating and referring to the same whole and understanding that unit, and also decomposing the fraction. If you notice here below, you can see in the visual that we want students to understand how we can break those pieces and to be able to justify those pieces. And so that's the key part in this standard. And Dee talked about earlier the significance of talking about equivalence and comparison. And so it's the idea that students have already spent time with equivalence and comparison prior to doing the operation. So they've had rich tasks put in front of them. They've had lots of experiences. And so this is a great segue into performing operations with a common denominator. So there are 5 interpretations of rational numbers, and these are discussed in detail in the IES document. But for today's session, we're going to focus on measurement. And Lamont talks about how measurement is a foundational concept for multiplicative reasoning, for lots of other reasonings, and all different forms and interpretations of fractions can be explained through this lens of measurement. And she talks about 3 measurement principles in her text. So we're going to continue with this idea of talking about fraction operations, addition and subtraction, and focusing on that measurement component. And so I have, if you see the quotes, this idea that we have 4 1/5 units. And so we can continue to talk about that as we move forward. And as we're talking about that, we need to change how we talk about fractions around students. And this idea of the unit is significant, and the 2 tells us how many. And so this is the view and how we want to talk about fractions with our students. And this idea continues on, and you've seen this slide in Cindy's presentation, this idea of units that carries forward, so that when students are attaching new knowledge to previous understandings, they're able to make this progression smoothly. So we start off, in kindergarten talking about teddy bears and different contexts when they're younger, and these get more sophisticated as they progress along the continuum to eventually to algebra. And one thing that I noticed in the Van de Waal text is that students' success with completely understanding fractions has implications on their understanding in algebra. And so we see that, and I added this slide at the last minute because I wanted to give you all some groundwork for what's to come, right? So these are different examples of where students will see fractions beyond elementary. And so we want to provide our students these rich contextual experiences, and so that when they get here, there's not a lot of misconceptions. And so as a former high school practitioner, I would see often whenever we talked about reciprocals or talked about direct and indirect variation, I could tell students who didn't have those experiences working about fractions with just the common denominator, just looking at the pieces, just decomposing. So without these experiences, they're not able to build upon that common knowledge and apply it to other more complicated concepts, such as proportional reasoning, such as this idea of force that they would explore in physics. And so can you imagine a high school freshman entering their integrated science course, and they're asked to explain the nature of force given the distances, and they don't have a firm understanding of what a fraction is or what it looks like or what the numbers or units mean. And so this is where we want to be mindful of this work that we spend on the lower end, making sure that students have lots of experiences with working with those different models, with the manipulatives, with the number line, with linear models, and so that when they progress later, those misconceptions do not resurface. And so I wanted to provide for you a contextual example, and if you wanted to scan this will take you directly to this Colorado Fed demonstration. And so one thing that the authors talk about is providing context for students, giving them rich tasks, and allowing them to manipulate the pieces with their hands. There's something about this dynamic movement and being able to manipulate the pieces that just brings about the understanding for students. So this is just an example that you can go directly there and you can play around with these pieces. Colorado Fed does a really good job of bridging those math and science concepts. And so you can go there and check out some different things that you can use, demonstrations that you can use in the classroom and that your students can use as well. Another point I wanted to make out is if in case you have students, let's say you are a middle school teacher or you're an interventionist, and you notice that these misconceptions are resurfacing, you can go to these simulations to review for kids and give those examples. Even though they've already learned the algorithm, you can give them opportunities to explore with that through these different websites. So I just wanted to shine light on that. And so let's look at decomposing fractions. And I'm sure you guys have seen this example before in the courseworks that we've offered with intermediate fractions. But it's the idea that we have 8/5 and the students can actually see the pieces there and they're able to name the pieces, and then they're able to break the pieces into mathematical sentences, okay? So the idea is that we have these 6 pieces that make the whole, and so notice how we're not avoiding fractions where the numerator is larger than the denominator. That's okay. We're not gonna call it an improper fraction. It's just a number that's larger or a fraction that's larger than 1. And so with that, we reduce those fears of different numbers that we don't understand. So they are just bringing those pieces together and using this model, they can add the pieces. They're not discouraged from manipulating the pieces around, and they can see how the concept bridges with the procedure, before the procedure. So is the idea here is that the students make the inferences themselves. I think that when we give them the procedure too early, we're spoiling the punchline. I think we should hold back on the punchline of the procedure and let the students explore this through their exploration with models. And so that's what we have here. And so here's another example of that. So you want students to think, I have 3/5 here and 4/5, and together that's 7/5. And to avoid that counting and just counting, but understanding the partitioning and understanding the pieces. And I'm seeing some of the comments, fractions are numbers, and getting students to be familiar with this. You'd be surprised on the secondary end how many students come into the gate without this understanding, without these experiences. And so immediately when they see a rational number, they panic and they freeze. And so as the idea is that they're comfortable, they've had these experiences. And so one activity I wanted to show for you guys was the color fraction wall activity. And if you've attended any of the intermediate courses, you've seen this before, but I actually saw this activity in action when I was, before quarantine, I was at Grant Lake Elementary, and the students were coloring and they were showing the equivalences, and it was no problem. But anyway, this is how the game works. You have 2 cubes, and you number 1 cube accordingly, and then you have stars on the other cube. They roll the cubes, and students have to color in the fraction that they found. And so I thought this was a really good activity. Experiences with fractions, manipulating those linear models is what the students need in front of them. And so here's a picture of the color fraction wall activity. And so think about this. How would you, if you were playing this game, how would you color 2/3? And what would be some things to consider? You guys can chime in if you want. You can write in the chat. How would we color 2/3 here? And what do you think a student would do if they were given this opportunity? Anybody? How would we color 2/3? Well, we could color 2/3 this way, right? We can, and you can see from the picture here, students would need to have some time with equivalence to know where and how to move forward in the activity. But I think this is a good example. And they could also color in the purple, is what someone was saying. And so I wanted to show this because this is a great example of that addition. So without them doing an addition problem, that's what they're doing. And so these types of experiences help them prior to getting the algorithm and the procedures. I also wanted to share with you the online version. And so this is a digital version that I thought was really neat, and I wanted to share with you guys. And so I'm gonna see if Adobe Player is gonna allow me to run. And so here is the digital version, and you can play this with students in the same way you do the paper version. And they have different levels, and so you would then take turns, right, to roll. I'll show you guys here. Let me move some things around, and then you can fill. Whoa. Let's see how it works. So you would roll here, and then I guess you would click on what you would want to fill, and then the other person would then roll, and then they can click on what they would want to fill, and so on and so forth. And so I think having a digital version is just another way to demonstrate these ideas, especially in these times where we can't be face-to-face. And so another way we can give students experiences with fractions or with C-rods in addition to subtraction. You can also use tangrams, but the C-rods, the text and the research that we were looking at, they talk about using those linear models and using that as a segue. The linear models of the C-rods and the number lines that Dee was talking about yesterday as a segue before the procedure. So all of these experience prior to the procedure is what our kids are needing. And so I was just provided a visual of what you could do with the C-rods in addition. And we talk about C-rods a lot in the courses, in the intermediate courses, if you've ever attended those, but you can use them to talk about a contextual problem. On Monday, I ran this far. On Tuesday, I ran this far. So then I could use the last line to say how many miles or how far did I run on the third day. So then you can make that conversion there. And you can also use the C-rods to show and model that addition. And so you can do the same as with a subtraction. And so you could say, how much further did I run on Tuesday? So all of those things work for models. Additionally, like you were shown yesterday in Dee's session, you can use number lines to demonstrate addition and subtraction. So the idea here is how many hops does it take to get from one starting point to the other? And so students then can demonstrate those hops. So that's 1, 2, 3, 4. You know, how many hops did it take to get to this value? And so using the number line for addition and subtraction and using those Jamboards that Dee shared with us yesterday are another great tool providing those experiences for students. Another simulation I wanted to show you guys was with Geogebra. Once again, this is another tool that you can use. Maybe you're teaching middle school, maybe you're teaching interventions in high school and you want to review. I think these are good simulations to assist with these ideas, because if you think about students who have moved on, they have these misconceptions, and so you want to provide them as much context as possible to address those. So I'm going to go here just to demonstrate this fraction activity. Now, you can use this fraction activity, and it's already created for common denominators or uncommon denominators like you see here, and you can change them if my computer would let me. And so the idea here is that you can change these values, and then you can show how the addition is happening. And so, just a second. If you look here, I have 2/4 plus 1/4, and here's the dynamic part. See how the slide in the movement? I think that's where the power lies, in seeing the movement, seeing what's happening as we combine these pieces, and then the number line representation right there. And so you can use this to represent addition with a common denominator or uncommon denominators, and using the same idea. And then you can add a context or a story to match the picture. And so here I'm going to add 2/5 and 1/5. It automatically changes the partition. And then you can see the dynamics with the sliding down to combine. And so then students are able to make inferences about the sum. So I think that GeoGebra really, really helps with dynamic movement and helping students understand what's happening in the mathematics. And then you can just follow up with questions. What do you notice? What do you see? How did this happen? What do these units mean? And so these are great tools, in my opinion, to help with these ideas. And so I wanted to share those with you. And so basically summarizing the work from all three of these texts, if it can be summarized, what works when we're teaching fractions? Giving context, and I have a visual there. If you can use any context that the students are familiar with so that they can use that as a jumping point in understanding. Provide for them candy, cakes, food, whatever context that they are familiar, and then give them a rich class and task and let them just explore, and don't give away the punchline. So let them figure out, oh, if I put all these pieces together, well, that's like I'm adding all these pieces, and this is the unit of measure. So giving them those experiences with that. A variety of models, using measurement to drive these models. Providing linear models, using that as a segue before you get to the abstract models. Area, C-rods, tangrams, any of the digital platforms, these are all a variety of models and experiences that students need to develop this understanding. Estimation and independent methods. And even though we didn't spend a lot of time talking about those, have students predict what would happen before the pieces move. Predict if I'm combining these, what are your inferences of what would happen and why does this make sense? And also addressing those misconceptions head on, and having the students talk about their reasoning while they're going through the problems, and then addressing those misconceptions as they surface. So I think these are all great strategies and great ideas to keep in mind when we're teaching fractions, and also to keep in mind when we're doing interventions on topics concerning fractions and rational functions later on. And so we're done a little early today, but you can feel free to provide any comments or share or anything you want to say at this point. You can feel free. Coming up, we also have this continuum. So tomorrow we'll talk about fraction operations with unlike denominators. And then we'll end the week with fraction operations with multiplication and division. So,
Leah, we can always count on you to have some really cool digital tools. And that was a hit today. At the end of every session, we appreciate when you unmute your mic and give our host a shout out on something that was new thinking for you, new learning, maybe a new tool. So we encourage you to unmute.
That was adding the fractions. My son is in 4th grade, and I could see how that would help him, seeing not to add the denominator, but give him a visual representation. So for that digital resource, especially during these crazy times.
Yeah, I love the digital tools. I think that's, I know for our district, looking at how we're going to help our teachers and how we're helping students with online learning, that those are very, very helpful tools for us. So thank you for sharing.
welcome.
Jennifer, we really are thinking more deeply about those virtual manipulatives and how that technology tool can really help kids to take a look at it, because as we've talked about as a center, we said that the actual physical manipulatives, the teachers everybody's gonna need to have their own set, right? They're gonna need to have their own set. They're gonna need to make sure that they're clean. And so virtual manipulatives are gonna be important.
I appreciated the glance forward into where this goes into the middle grades and the high school, because it's this message I keep trying to send to people, because you can't shortchange those early experiences thinking that this is easy. They're just adding the
Right.
graders. Why do we make this so complicated? Because it is actually fairly complex. There's a lot more depth to it than people know. And so what happens when we shortchange it is they walk into middle school without a real sense of what rational numbers are. They don't understand fractions, so they can't get into the more complex pieces. And then algebra is hard if you don't have that reasoning. So I like that you gave us that glance forward.
Great.
So at the Kentucky Center for Mathematics, every afternoon we do a 2 o'clock Zoom session. This week is focused on fractions, and we are so glad that you guys are dedicated to us and tune in every afternoon. So we thank you so much, Leah, for sharing your knowledge, your digital tools, and again, like you said, that gets forward. We'll see you tomorrow. All right. Thank you, everybody.
Thanks, guys. Appreciate you.